Hello, welcome back. I'm John, old YouTuber. I just made an English vlog video with my old camcorder there. It's Saturday evening, and I've been a little bit tired most of the day. But I had to break like 2 days reading this PDF. I read this PDF because I like to do it, but could have this. I need to read this microcontrollers, vacuum tube, transistors and stuff. But I start. I had a break like 2 months reading this PDF, and then I did buy this. Old ASA Aspire, this old gamer computers. One of them have a Pentium D or Pentium dual core. So I did like to read about the Pentium. So we could do that. We could just keep it there. I have to read the Pentium original. Let's find it. But I should, that's a few days old. I should maybe download a fresh copy. Let's do that. We spent a few minutes to do that. Let's download a fresh copy of the Pentium, because that maybe 1 week ago I did download. So I need to find it. The Pentium. Yes, I did 23 August. Now we know, so that's 10 days ago. So let's copy the text and close it and open Wikipedia. English and insert Pentium original. Yes, it was last edit 13 August. Because that's 10 days ago. Good. Then I have to find it again and delete the old one. Yes, delete the old, delete and rename, because they put a number 1, because I already had. Good, then open. And sound 52 or 54, something like that. So let's do that. It's 9 p.m. It's only 6 pages. So, and I'm always thirsty. Let's read it properly. It would be could be a 1-part video. Yes, I need half a minute to do myself ready in my bed. So, but probably it would be 2-part video, because I have talk so long time.
Pentium, original. Pentium Intel Pentium MMX processor logo.svg. General information launch March 22, 1993 discontinued February 15, 2001. Performance max. CPR clock rate 6300 MHz FSB speeds 5066 MSCHL 1 cache 1632 KIB architecture and classification architecture 5 IA32 instructions MX physical specifications socket S socket 4 socket 5 socket 7 products models variants model S Pentium series Pentium Overdrive Series Pentium MMX Series History predecessor Intel 80486 successor P6 Pentium 2 The Pentium, also referred to as 5P, its microarchitecture, is a 5th generation 32-bit x86 microprocessor that was introduced by Intel on the 22nd of March 1993 as the very first CPU in the Pentium brand. 3. It was instruction set compatible with the 80486 but was a new and very different microarchitecture design from previous iterations. The 5P Pentium was first superscalar x86 microarchitecture and the world's first superscalar microprocessor to be in mass production, meaning it generally executes at least 2 instructions per clock, mainly because of a design-first dual integer pipeline design previously thought impossible to implement on a CISC microarchitecture. Additional features include a faster floating point unit, wider data bus, separate code and data caches, and many other techniques and features to enhance performance and support security, encryption, and multiprocessing for workstations and servers when compared to the next best previous industry standard processor implementation before it. The Intel 80486. Considered the 5th main generation in the 8086 compatible line of processors. Its implementation and microarchitecture was called 5P. As with all new processors from Intel since the Pentium, some new instructions were added to enhance their performance for specific types of workloads. The Pentium was the first Intel x86 to build in robust hardware support for multiprocessing similar to that of large IB mainframe computers. Intel worked closely with IBM to define this ability, and then Intel designed it into the P5 microarchitecture. This new ability was absent in prior x86 generations and x86 copies from competitors. To realize its greatest potential, compilers had to be optimized to exploit the instruction-level parallelism provided by the new superscalar dual pipelines, and applications needed to be recompiled. Intel spent substantial effort and resources working with development tool vendors, and major independent software vendor, ISV, and operating system, OS, companies to optimize their products for Pentium before product launch. In October 1996, the similar Pentium MMX 4 was introduced, complementing the same basic microarchitecture with the MMX instruction set, larger caches, and some other enhancements. Intel Pentium 8050166 MHZSX950 die-image competitors included the Motorola 68040, Motorola 68060, PowerPC 601, and the Spark, MIPS, Alpha families, most of which also used a superscalar in order dual instruction pipeline configuration at some time. Intel discontinued the 5P Pentium processors, sold as a cheaper product since the release of the Pentium 2 in 1997, in early 2000 in favor of the Celeron processor, which had also replaced the 80486 brand. 1. Contents. Development improvements over the i486. Errata. cores and steppings P5, P54C, P54CQS, P54CS, P24T, P55C. Tillamook. Models and variants. Competitors. See also competitors. References. External links: Intel data sheets, Intel manuals. Development. The 5P microarchitecture was designed by the same Santa Clara team which designed the 386 and 486.5. Design work started in 1989. Winking sad smiley 6. The team decided to use a superscalar architecture, with on-chip cache, floating point, and branch prediction. The preliminary design was first successfully simulated in 1990, followed by laying out of the design. By this time, the team had several dozen engineers. The design was taped out, or transferred to silicon, in April 1992, at which point beta testing began. 7. By mid-1992, the 5P team had 200 engineers. 8. Intel at first planned to demonstrate the 5P in June 1992 at the trade show PC Expo, and to formally announce the processor in September 1992. 9. But design problems forced the demo to be cancelled, and the official introduction of the chip was delayed until the spring of 1993. 10. 11. John H. Crawford, chief architect of the original 386, managed the design of the P512, along with Donald Alpert, who managed the architectural team. Drawfnan managed the design of the FPU. 13. Vinod K. Dam was general manager of the 5P group. 14. Intel's Larrabee multi-core architecture project uses a processor core derived from a 5P core, P54C, augmented by multi-threading, 64-bit instructions, and a 16-wide vector processing unit. 15. Intel's low-powered Born-or microarchitecture employed in early Atom processor cores also uses an in-order dual pipeline similar to P5. 16. Intel used the Pentium name instead of 80,586, because it discovered that numbers cannot be trademarked. 17. Improvements over the i486. The 5P microarchitecture brings several important advances over the prior i486 architecture. Performance superscalar architecture. The Pentium has two data paths, pipelines, that allow it to complete 2 instructions per clock cycle in many cases. The main pipe, U, can handle any instruction, while the other, V, can handle the most common simple instructions. Some adjacent instruction set computer, RISC, proponents had argued that the complicated x86 instruction set would probably never be implemented by a tightly pipelined microarchitecture, much less by a dual pipeline design. The 486 and the Pentium demonstrated that this was indeed possible and feasible. 64-bit external data bus doubles the amount of information possible to read or write on each memory access and therefore allows the Pentium to load its code cache faster than the 80,486. It also allows faster access and storage of 64-bit and 80-bit x87 FPU data. Separation of code and data caches lessens the fetch and operand read forward/write conflicts compared to the 486. To reduce access time and implementation cost, both of them are two-way associative, instead of the single four-way cache of the 486. A related enhancement in the Pentium is the ability to read a contiguous block from the code cache even when it is split between 2 cache lines, at least 17 bytes in worst case. Much faster floating point unit. Some instructions showed an enormous improvement, most notably FMUL, with up to 15 times higher throughput than in the 80,486 FPU. The Pentium is also able to execute a FXCHST-X instruction in parallel with an ordinary arithmetical load/store FPU instruction. 4-input address adders enables the Pentium to further reduce the address calculation latency compared to the 80486. The Pentium can calculate full addressing modes with segment base and base register and scaled register and immediate offset in a single cycle. The 486 has a 3-input address adder only, and must therefore divide such calculations between 2 cycles. The microcode can employ both pipelines to enable auto-repeating instructions such as rep moves perform 1 iteration every clock cycle, while the 80486 needed 3 clocks per iteration, and the earliest x86 chips significantly more than the 486. Also, optimization of access to the first microcode words during the decode stages helps in making several frequent instructions execute significantly more quickly, especially in their most common forms and in typical cases. Some examples are 486 Pentium, in clock cycles call 3-1, ret, 5-2, shifts forward/rotates, 2-3-1. A faster, fully hardware-based multiplier makes instructions such as MUL and IML several times faster, and more predictable, than in the 80486. The execution time is reduced from 13 to 42 clock cycles down to 10-11 for 32-bit operands. Virtualized interrupt to speed up virtual 8086 mode. Branch prediction. Other features: enhanced debug features with the introduction of the processor-based debug port. See Pentium processor debugging in the developer's manual, Vol 1. Enhanced self-test features like the L1 cache parity check. See cache structure in the developer's manual, Vol 1. New instructions. PUID, CMPXCHG8B, RDTSC, RDMSR, WRMSR, RSM. Test registers TR0, TR7 and MOV instructions for access to them were eliminated. The later Pentium MMX also added the MMX instruction set, a basic integer single instruction, multiple data, SIMD, instruction set extension marketed for use in multimedia applications. MMX could not be used simultaneously with the x87 FPU instructions because the registers were reused to allow fast context switches. More important enhancements were the doubling of the instruction and data cache sizes and a few microarchitectural changes for better performance. The Pentium was designed to execute over 100 million instructions per second, MIPS, 18, and the 75 MHz model was able to reach 126.5 MIPS in certain benchmarks. 19. The Pentium architecture typically offered just under twice the performance of a 486 processor per clock cycle in common benchmarks. Fastest 80,486 parts, with slightly improved microarchitecture and 100 MHz operation, were almost as powerful as the first-generation Pentiums, and the AMD M5x86 was roughly equal to the Pentium 75 regarding pure ALU performance. Errata. The early versions of 6100 MHz 5P Pentiums had a problem in the floating point unit that resulted in incorrect, but predictable, results from some division operations. This flaw, discovered in 1994 by Professor Thomas Nicely at Lynchburg College, Virginia, became widely known as the Pentium FDIV bug and caused embarrassment for Intel, which created an exchange program to replace the faulty processors. In 1997, another erratum was discovered that could allow a malicious program to crash a system without any special privileges, the F00F bug. All 5P series processors were affected and no fixed steppings were ever released. However, contemporary operating systems were patched with workarounds to prevent crashes, cores and steppings. The Pentium was Intel's primary microprocessor